Welcome to video 7 in this DIY off-grid and solar video series. This is an update on the solar production from 2020. Second, I have some information about if solar is a legitimate way to prepare for prolonged power outages. And lastly, if solar cannot meet 100% of the need, I am going to present data about how to use an internal combustion engine generator in conjunction with a home battery. This graphic is 18 months of solar production from my DIY solar panels project. The black bars on top are the consumption that was met with power from the power company, and the green bars are what the solar panels gave. I did work from home a lot in April 2020, and it was also a record sunny spring in Ohio, so the May 2020 utility bill was a record low 210 kWh. Then through the summer I consistently made 700 kWh from July to October. I found that from December and in January 2021 I had my lowest production to date with a 900 kWh purchase from the power company. In balance, I saved almost $1,150 in this time period and reduced my year-over-year power consumption by 55%. These are my power bills from before solar on the left, and after the solar is up and running on the right. I circled here how I went from 12,000 kWh to 5500 kWh per year. This chart shows the energy each day for the last 18 months. What I see here is that sunny days happen all year, with corresponding large amounts of kilowatt-hour captured in that day. Obviously though, there are a lot less sunny days in the winter than this summer. And the irony here is that this is when I would most need an off-grid power system. So I needed to quantify the risk of having a dead battery on a dark cloudy day when a nasty winter storm came in with power-killing ice buildup. This chart is the probability, based on the last 18 months data, that on any given day in a month that my solar power system will provide a usable amount of energy. I changed the units to read out in how many kilowatt-hours relative to the amount of kilowatt power of the panels, so this is scalable for more or less panels. It is based on Toledo, Ohio, so Texas will be better and Alaska will be worse. What it shows is that if in January if I want to get 2 kWh/1 kilowatt power panel, I only have a 16% chance of that happening. Even a modest requirement of 0.5 kilowatt power panel in January is only achieved 70% of the time, which for me would be 2.5 kWh day. Hardly enough to run more than my fridge, let alone a space heater when it's 0 degrees Fahrenheit. One solution is to have a fossil power generator, but we saw in Texas recently that even natural gas pumping station can be knocked out if the power outage is widespread enough. At least one of the fuels for the generator has to be on site. Also, the fuel has to be safe and reliable. That's why I have a natural gas, propane biofuel generator. To make it so I can power myself through a winter outage when the solar is not there. This is my generator with a Century Fuel Systems conversion kit installed on it. Their silver disc is the demand regulator, and I modified my carburetor to have a so-called spud tube to replace the main gasoline jet, see here from the engine side of the carburetor. I can connect this to my natural gas supply or connect a propane hose and run it from propane tanks. Keep in mind that running a gaseous fuel will reduce generator output 30%, because the fuel vapor displaces the air with its oxygen. So mentally derate the generator by this amount so that you know what you're getting. One issue with the DIY fuel conversion kits is that they need to be adjusted or tuned to your engine, and this chart shows how anyone with a simple digital multimeter can set the air-to-fuel ratio correctly. This chart shows my generator loaded down past the point that it can make the correct frequency. At a low load it will make 60 Hz power because the governor will control the engine's speed, but if the electrical load is too great the frequency will drop lower than 60 Hz. The plot shows that it's around 50 Hz and the governor is wide open here. Then I adjust the fuel screw on the demand regulator while also measuring the frequency of the AC power. When the air-to-fuel ratio is set correctly, then the frequency will be the highest and it will go down if it's opened or closed either way. Here I'm showing that with natural gas and a worn-out flathead engine, peak power is at 92 lambda or 8% excess fuel. Know that when tuned to make maximal power the engine will be making carbon monoxide in its exhaust, so never ever allow this poison gas to enter your house from the window or garage door. How ironic to perish from something intended to make life more comfortable. So at this point in the video we see that we can get a generator and use it for days that solar power is too low to use. But this table here shows why that alone is not a good idea. Most of the time a modest house uses a relatively small amount of power, between 500 and 1000 watts at any given time. However, most generators need to have a rating of 5000 watt to have enough surge power to start a motor, like the one in the fridge or freezer. But the issue here is that engines are most efficient in turning fuel into energy at full power, and at even half load the amount of fuel used to make that smaller amount of power is a much lower efficiency. The fuel use goes down but not linearly, because the efficiency of fuel to mechanical energy conversion goes down too. This table shows that I had a 20% efficient at full load, but at 1/8 load, the power level the generator will be used at it's about 6% efficient. This slide is from the Generac website and they show here that their large propane generators can make more than 5.5 kWh per gallon of propane, which is good. But they also show at half load that deal gets worse. They don't show their fuel usage at near idle, but it's still going to be a good fraction of a gallon an hour. So this is the takeaway. Running a home on a backup generator alone at an average power level of 750 watt-hour will use about 16 gallons of propane, or gasoline to make the 20 kilowatt-hour needed. Over 90% of that expensive and hard-to-get energy is wasted, turned into heat and noise. Think of how hard it would be to haul 5 barbecue tanks every day to be filled or jerry cans to the gas station, of course assuming the gas station are even open, which they may not be. The solution is a home battery. Using the generator to change the home battery will use much less fuel than running on the generator alone, because the generator can be utilized at full load, so it will be running where it's 20% efficient. And that same 20 kilowatt-hour of electrical energy will take 3.5 gallons of fuel, which is about 4 times less fuel. And it will be quiet at night, without your generator hammering away, keeping the neighbors up and inviting a potential theft. Before beginning buying anything, people say that we should make an effort to understand how much power is needed in an emergency. According to the Energy Star website, a typical fridge will use 2 kilowatt-hour per day. A 1500 watt heater will use 7.5 kilowatt-hour per day when run for 5 hours. Another heating option, and one that I'm looking at, is a heat pump. The unit here is representative of a window air conditioning unit that has heat pump capability. There are also 1 to 2 ton mini splits that do the same thing, but make sure to get an inverter one, and also one that does heat pump heat, not resistance heat. This Frigidaire unit here, as an example, uses only 800 watts but provides the same amount of heat as a 1.8 kilowatt resistance heater. To summarize, this video was about using a solar power system as an emergency power backup system. The first step is to determine the critical loads measured in kilowatt hours per day, and add them all up. This could include a tea kettle, an EV, or a Xbox. But plan on the lowest temperature and also fuel shortages. Next, get as many solar panels as possible. Every solar panel is some amount of time less that the generator needs to run. While it may seem important to try to get the lowest price per watt on solar panels, I have found it's better to have a well-made solar panel and the balance of system is made of quality parts. Next, I suggest to get a 48-volt lithium battery. Don't even mess with lead batteries, they will hurt the payback of the system and require a level of maintenance at least I'm unwilling to put in. Also, 48 volt is the highest voltage that is touch safe, and has a solid support level in the industry. Then get an off-grid inverter. There are many good brands that I would consider: Magnum, Schneider Electric, Outback, Solar Arc, and others. You have to trust it with your life while you're sleeping. Then wire it into a load side transfer switch. This can either be a multi-circuit type or a large single switch and a critical load sub-panel. Onward, get a multi-fuel generator. I like dry fuels because they don't spoil in storage and keep the engine oil clean. Any generator will do, but the conversion costs can be over $200. There are more and more dry gas fuel generators on the market. Lastly, do it. A pile of parts won't help when the lights are out. Install and test it once or twice a year to keep the task in muscle memory. Also write it down. I'll leave you with the idea that we can choose to feed the ever-battling dark wolf of fear or white wolf of hope with our choices. Maybe this approach to solar and feeds the white wolf, giving the hope of saving on power bills, and reducing carbon output for your house, car and life. But then also acknowledge the dark wolf and plan for a disaster with the same equipment. Thanks and go solar.